Welcome to aminacademy.com. In material science and engineering, let us discuss about selection of materials. Material selection is an essential aspect of product design and development. An appropriate material should meet many basic criteria including efficient manufacturability, performance, reliability, non-degradability and recyclability. Material science and engineering plays a vital role in this modern age of science and technology. Various kinds of materials are used in industry, housing, agriculture, transportation, etc. to meet the plant and individual requirements. The rapid development in the field of quantum theory of solids have opened vast opportunities for better understanding and utilization of various materials. The particular success in the field of space in primarily due to the rapid advancement of high temperature and high strength materials. Here, the selection of material consider the factors manufacturing process, functional requirement, cost consideration and operation parameter. There are millions of materials available and it is very difficult for an engineer to possess a detailed knowledge of all the materials. However, a good grasp of the fundamental principles which control the properties of various materials help one to make the optimum selection of materials. The subject of material science is very vast and unlimited. Broadly speaking, one can subdivide the field of study into following four branches: science of metals, mechanical behavior of materials, engineering metallurgy, engineering materials. Now we'll discuss the factors. First, engineering requirements. While selecting materials, While selecting materials for engineering purpose, properties such as impact strength, tensile strength, hardness indicate the suitability of selection, but the design engineer will have to make sure that the radiography and other properties of the material are as per the specification. In recent years, polymeric materials or plastic have gained considerable popularity as engineering materials. Though inferior to most metallic materials in strength and temperature resistance, these are being used not only in corrosive environment but also in the places where minimum wear is required. For example, small gear wheels originally produced from hardened steels, but nowadays the nylon gears also in use. Now we'll consider next engineering requirements. First, mechanical properties. The important mechanical properties affecting the selection of materials are tensile strength. This enables the materials to resist the application of tensile force. To withstand the tensile force, the internal structure of the material provides the internal resistance. Hardness. Hardness is the degree of resistance to indentation or scratching. That means abrasion and wear. Alloying techniques and heat treatment help to achieve the same. That means what? The hardness is improved by alloying as well as heat treatment of the metal. Ductility. Ductility, this is a property of a metal by virtue of which it can drawn into wires or elongated before rupture takes place. It depends upon the grain size of the metal crystals. Next, impact strength. Impact strength is the energy required per unit cross-sectional area to fracture a specimen. That means how much load you have to apply by impact force to break the fracture the specimen. It is measure of the response of material to shock loading. Wear resistance. The ability of a material to resist friction wear under particular conditions. That is to maintain its physical dimensions when it sliding or rolling contact with the second member. That means what? Wear resistance is with contact and rubbing with other materials, how the materials not to wear. Corrosion resistance. Those materials and alloys which can withstand the corrosive action of medium, that is corrosion process in them at a relatively low rate or term corrosion resistance. Mainly corrosion resistance is considered when environment of that usage. Next, density. We know that this density is the important factor of material where weight and thus of the mass is critical. That is aircraft component. Those things we consider mainly the density of the material. That means less weight, more effect. That means less weight, more strength. Next, we consider thermal properties. The characteristics of a material which are functions of the temperatures are termed its thermal properties. One can predict the performance of machine components during normal operation if he has the knowledge of thermal properties, specific heat, latent heat, thermal conductivity, thermal expansion, thermal stress, thermal fatigue, etc. are few important thermal properties of materials. The properties plays a vital role in selection of materials for engineering applications. That is when the materials are considered for high temperature service. Now we briefly discuss the things. Specific heat. As what is specific heat? It is the heat capacity of a unit mass of homogeneous substances. For homogeneous body, C is constant, where C is the heat capacity and mass of the body. C equal to C specific heat capacity C is equal to heat capacity by mass of the material. Thermal conductivity. Your thermal conductivity K, which is defined as this represents the amount of heat conducted per unit time through unit area perpendicular to the direction of heat conduction when the temperature gradient across the heat conducting element is 1 unit. That means K equal Qx over A theta 2 minus theta 1, which is in units of watts per meter per Kelvin. Next, thermal expansion. Thermal expansion. All solids expand on heating and contract on cooling. Thermal expansions may take place either as linear, circumferential, or cubical. A solid which expands equally in three mutually orthogonal directions is termed as thermally isotropic. The increase in any linear dimension of solid, that is length, width, height, on heating is termed as linear expansion. The coefficient of linear expansion is the increase of length per unit length per degree rise in temperature. The increase in volume of a solid on heating is called cubical expansion. The thermal expansion of solids has its origin in the lattice vibration, and lattice vibration increases with the rise in temperature. Therefore, thermal expansion, that is, you can see L alpha T. L alpha is the thermal expansion, length, original length of the body, and alpha is coefficient of thermal expansion, and T is the temperature changes. Next, thermal diffusivity. Here, thermal diffusivity, it is given by thermal conductivity by heat capacity into density. Thermal diffusivity, diffusivity, which means thermal conductivity K over heat capacity Cp into density rho. The material having high heat requirement per unit volume possesses a low thermal diffusivity because more heat must be added to or removed from the material for affecting the temperature change. Next, thermal fatigue. What is thermal fatigue? Thermal fatigue, this is the mechanical effect of repeated thermal stresses caused by repeated heating or cooling. The thermal stress can be very large, involving considerable plastic flow. We can see that fatigue failure can occur after relatively few cycles. The effect of the high part of the temperature cycle on the strength of material plays an important factor in reducing its life under thermal fatigue. Now next we'll discuss about electrical properties. The conductivity, resistivity, dielectric strength are few important electrical properties of material. A material which offers little resistance to the passage of an electric current is said to be a good conductor of electricity. Now we can write resistance is equal resistivity into length over cross-sectional area, cross area. These are resistance is resistivity into length over cross area. Usually, resistivity of a material is quoted in some authors. Unit of resistivity is ohm meter. It is resistivity is ohm meter. On the basis of electrical resistivity, materials are divided as conductors, that is a good conduction of heat, and semiconductors, semi-level, and insulators, that means insulators not conduct easily the electricity, that is insulators. Whereas conductor is good conduction of electricity, semiconductor is of conduction, that means it's varying, and insulators, it is not conducting the electricity. We know that in general, metals are good conductors. Insulators have very high resistivity. Ceramics insulators are most common examples and are used automobile spark plugs, backlight handles for electric iron, plastic covering on cable in domestic wiring. These are the uses of insulators. Magnetic properties. Materials in which a state of magnetism can be induced are termed magnetic materials. These are five classes into which magnetic materials may be grouped, that is diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic. Iron, cobalt, nickel, and some of their alloys and compounds possess a spontaneous magnetization. Magnetic oxide like ferrites and garnets could be used to high frequencies. Next one, chemical properties. These properties include atomic weight, molecular weight, atomic number, valency, chemical composition, acidity, alkalinity, etc. These properties govern the selection of materials, particularly in chemical plant. Next, optical properties. The optical properties of materials, for example, a refractive index, reflectivity, and absorption coefficients, etc., affect the light reflection and transmission. Structure of material. The properties of engineering materials mainly depends on the internal arrangements of the atoms or molecules. We must note that in the selection of materials, the awareness regarding differences and similarities between materials is extremely important. Metals of a single type atom are named as pure metals. Metal in actual commercial use are almost exclusively alloys and not pure metals because alloys are more strengthened than pure metals. Now, so far we discussed about material selection in engineering field. We have done. Please subscribe our YouTube channel.